This is the virtual machine view within a Grafana dashboard via the Service Telemetry Framework. The underlying system is an OSP 16.1, which is sending and collecting data via collectd and ceilometer. That data is transported via the AMQ Interconnect message bus and is stored into the storage backend, which is consisting of Prometheus and ElasticSearch. In this view, we'll be showing the various projects that exist inside of an OSP 16.1 cloud, and the virtual machines will be available within this view. So this project here has a single virtual machine instance available to it. And what we'll do is we'll log into the OpenStack dashboard. Within this dashboard, we currently have that single virtual machine that is available. We'll create a new instance, and we'll call it Demo2. And we will launch it. We've scheduled the creation of a new instance on this project. And if we go back to our virtual machine view, once that instance is launched, we will get a notification saying that the compute instance creation has started. We will also see a second event saying that it is finished. Once that has completed and the virtual machine is available and data is being collected, our virtual machine instance count will increase by 1 to a count of 2, and we will see the CPU percentage, the CPU time for the instances, memory, network, and disk information for the virtual machines. As the instance starts up, the data for the CPU will spike, and it will then settle back down to an idle level. We can also zoom in on the time range by dropping down from 30 minutes to the most recent 5 minutes. And we also have a list of virtual machines here on the left. In addition to the virtual machine view, when we're monitoring our OSP 16 cloud, we can also monitor the infrastructure. So we can go to our cloud overview panel, which will show us information about our system. It'll give us a list of active alerts, which are pending here, and our aggregate CPU usage, our system load, memory, network, and an overview of all the machines in our cluster. I'm going to overload the controller 0 so that we have an active alert firing. So we'll stress the system out. And while that is running, we'll be able to see our controller 0 will start to spike. We've noticed here that our high CPU load is in a pending state for controller 0, and we can see that here on our dashboard. And if we highlight over top of it, we can see that our controller 0 is at 79% CPU load. We can also drill down into this controller, going to the infrastructure node dashboard, and this will also give us the alerts that are available for this machine, specifically its current CPU usage, and a host of other bits of information around this host. If we select other hosts that we have available in our list here, we'll see that other nodes are fine and that their current status is low utilization and no active alerts. If we stop our stressing, the machine will eventually here start to recover, going back to a CPU usage more idle. We can see that our current CPU usage has already started to drop. And as the CPU usage continues to stay at closer to an idle level, our alerts will start to clear. We can look at the configuration of these alerts. And this is the high CPU. And here's the expression showing within the Prometheus UI that we currently have no alerting. If we rerun our stress in order to get the information back into the system, we can continue to watch this. We can see that now we're getting data back. We can view our graph. Here's previous alerts that would have been active and matching this expression. We can go into our alerts dashboard and we can see any active alerts for the system, including our high CPU. It's currently in our pending state that we saw earlier. And after it's been in the level for 30 seconds, our severity of critical will start to fire. So this pending state will adjust and move from pending to firing once the CPU load has been active for a period of time. We can see the period of time has elapsed. For more than 30 seconds, our CPU load has been higher than 1.5, and now we're in an active firing state. If we stop our stressing, at this point, the system again will start to recover. Our alerts will also start to recover after about 30 seconds. Our alerts are recovered, and our system is now back to an operational state. Our dashboard confirms this. We no longer have our high CPU firing alert, and we can see our CPU usage has started to drop back down to a more reasonable level. And that's the Service Telemetry Framework.